Do you need a pencil, Hazel? Is there a theta about which we are concerned? There is. What is its value? X. Once we have X, that's where we are sitting in the triangle. I look like a pineapple today. Which makes this 35 what? Opposite. And that makes this 50 what? Since I have both of them, it must be a shift tan situation. So what is theta? $35 degrees? Easy peasy. I hope. I didn't check. It's not 30 degrees, or 30, it is 35 degrees. In the second question I asked you to do, is there a theta about which we are concerned? There is. What is its value? 60 degrees. Once I have theta, that's where our starting point is. Oh, I left one of my hairs there, just like real life. I'm going bald. What is that X? Opposite. What is that? That. What can I use there to find X? Tan theta is O over A. So tan of 60 is X over 7. Number in the denominator, 7 tan 60 equals X. What is X? 12.1. Now, is X really 12.1? Let's find out, shall we? 7 tan 60. No. X is 7.12435565. But we're going to write 0.1 because we're not going to write all that out. How do I find the best possible answer for Y? I use the ANS button. Now, if I'm uncomfortable with that ANS answer button, I can use 12.1, but my answer will be different from my teacher's answer by a couple of decimal places. Y squared equals X squared plus 7 squared. Now, X squared, we've written it as 12.1, but it's sitting on our calculator, yes? So I just go answer squared plus 7 squared equals that. And then what do? I square root that, and y squared equals 196, so y equals 14. And those are the two answers there. And lastly, is there a theta about which I am concerned? What is it? 80. Once I have theta, that means I am over here. Oh my goodness, I've lost hair and my head. I'm just 2 eyes and a smile now. I appear to have died. What is that 10? What is that X? And what does x equal? What is x? 1.8. Is everybody good with the beginnings of trigonometry? Yes? Okay. Now, angles in the real world. Please take the white space you have here, cut it in about 1/3, 2/3 up and down, and then cut the bottom section in half. So you have a T sort of situation going here. All right. Over here on the left, please draw a face. If you wish, you can add some accoutrement, like a tongue sticking out, or, frizzy hair, or whatever you need to be happy with the face. The only part of that face that really matters are the eyes. Because in the real world, the eyes are where we use to look at things, yes? All the angles we've drawn before are all written on a piece of paper. They are not real world angles. In the real world, angles look like this. If we have nothing to look at, nothing at all, our eyes look straight on the horizontal. Does everyone agree? So I have this line right here. And that is our line of sight. And it is horizontal. Now, some of you forget that the word horizontal means flat. Learn it. Everybody good? All right. Now, let's pretend that we're outside. We're minding our own business. We're walking down the street. And we hear a plane. No matter how cool you think you are, when a plane flies over you, what do? You all look up at the plane. Every single one of you. No matter how cool you think you are, if a plane flies over, I know this because I ref rugby games. In the middle of the rugby game, I will see kids, plane. And that's okay, because I do it too. So over by this D, sketch yourself a little plane. I don't care how much, again, detail you put into it. There we go. I got my plane, got my tail fin, got my engines. You know how it is. Right? Plane is flying over. Where do my eyes go? Up. So my line of sight goes from the horizontal to where? Up to the plane, yes? Making what at my eye? An angle. Since my eye went up, this is called an angle of elevation or inclination, because my eyes went up. Is everybody good? All right. Now, let's pretend that you are walking along, the plane has flown over, where have your eyes gone? Back to the horizontal. And then you notice on the ground some money. Now where do your eyes go? Down to the money. Creating what? Another angle. This angle is called the angle of depression. Or declination. Because your eyes have gone down. Does everybody understand? Now, I do not want you to draw what I am about to draw. I want you just to think about it. Me. Plane. Yeah? What is this angle right here? Angle of elevation. Yes? All right. On the plane is a person looking out the window. That person's eyes are looking back behind the plane. That person sees me on the ground. This is an angle of elevation. Where is the angle and only angle of depression? Is it where the purple dot is, where the peachy dot is, or where the bluey dot is? The peachy dot is the angle of depression because it is the only angle that goes from the horizontal down. Now, what do you know about this angle of elevation and this angle of depression? They are equal. Because this person's eyes came down as far as mine went up. Please notice this and this are nothing. Everybody cool? It is all about where the viewer's eyes go. Everybody is good? Right now you are looking me in the eye. If I stand up, what will you have? Angle of elevation. And that angle of elevation will be between from eye to eye to up. Yes? If I drop a $100 bill while I am standing up, your eyes will go from where? Up to down to the $100 bill. And you will say, man, how's that guy got a $100 bill? He's always talking about how cheap and poor he is. Everybody good? Okay. Believe it or not, that is a really difficult lesson. You all have it, yes? Good. Now, that is one way we deal with angles in the real world. We look up, we look down. The other way is directions. And directions have two ways we can go about doing them. But they both share this. The compass rose. What direction do we say is always at the top? North. It's not at the top. We just choose it to be that way. The reason we choose it to be that way is because most of the people that invented this type of directions lived in the northern hemisphere and they wanted to be on the top of the map. That's the only reason. So this is what? East. This is what? And this is what? West. Never eat soggy wieners. Right? Never eat shredded wheat. There's a million of them. I only know those two. But every year some kid says a different one. I think they're starting to make them up. And they've never actually heard them. But whatever. What do you got? No. Never enter smelly washrooms. Good one. Never heard that one. Anyways. Now, ladies and gentlemen, there are two ways that we talk about directions. One way is on the 0 to 360 degree scale. North equals 0. East equals what? 90. South equals 180. And west equals 270. So if I tell Hazel to walk 1 kilometer at a heading of 48 degrees, where will Hazel be walking? To the northeast, approximately, yes? This will be Hazel's path. Agreed? Now, if we are going to do math with that, we need to make what shape to do to do trigonometry. I must make a triangle, which means I could go here or I could go here, yes? I told you Hazel was walking at 48 degrees. Where is the 48? Is it where the pink dot is, the green dot, the whatever baby puke yellow color that is, or this weird blue? Where is the 48, do you think? Where the pink dot is. Because you start at 0 and you go that way. So, you all agree that this is 48, yes? But that automatically gives us every other angle we could possibly need, doesn't it? We know this is 90. What is this? 90. What is this? 90 minus 48, which is 42. What is this? 48. What is this? 42. And now I could do all the trig I need to do. Everybody with me? Great. So now Sebastian is going to walk at 117 degrees. Where would that be? In a southeasterly direction, yes? So I will start here and go clockwise or counterclockwise? Clockwise. There's 90. I said we were going 117, yes? So down there. There's Sebastian's line. That was a nice straight line. What is this? What is this angle? Where my... No. It's 117 from up there. I can't do trig with that. What is this? Just this part, ladies and gentlemen. Just that.
27.
27. Which makes this what? 90 minus 27, which is? 63. Is everybody good with these kinds of directions? Going once, going twice, going thrice. Okay. There's another way we read directions. Draw another compass. North, east, south, west. And this way requires us to write a direction like this. You have a direction. You have a degree. And then you have another direction. So, if I tell Anu that he is going to walk north 47 east, this means I am going to start in that direction. I am going to adjust this far in this direction. So, if I just told Anu to walk north, he would go straight up here, yes? But he isn't walking north. Where is he walking? He is walking north, but he is adjusting 47 degrees to the east. So, if you guys are north of me, because I'm going that way, am I going to be turning right or left? I'm going to be turning right to the east. Everybody understand? And where's the 47? Is it there or there? Green. Oh, color didn't change. It is the first one. So if I was doing trig, I could make that triangle with 47 there, or I could make that triangle with 43 there. Everybody cool? All right, so I'm going to ask you to draw 3 more lines on here. Okay, I'm going to use 3 different colors. You're going to tell me all the angles that come from them. Everybody cool? All right, so I want you to give me, in this color, east 16 north. In orange, I want you to give me south 27 east. And in red, I want you to give me west 63 south. You guys don't need to use 3 colors. You just need to draw 3 lines. I will give you a few seconds to... Have no fear. I'll bring it back over there. There, see, everything I just said. You heard it, you remember it, it's all there, yeah? Yeah. All right. If I tell my good friend Toby, to take a hike, and I say, Toby, I want you to walk 6.2 kilometers north 29 east. So here is Toby at his starting position. North, once he is at his starting position, is always that way, yes? So I tell him to walk 6.9 kilometers north, what did I say? 29? North 29 east, yes? He is going to walk that way. Agreed? Where's the 29? Is it there or there? 29. Yeah? And how long did he walk? 6.9 km. Agreed? Now, after you've walked 6.9 kilometers, Toby, I want you to walk 8.3 kilometers south 28 west. So what must I draw here? Another one of these. Because he is going to walk south. How far? 28 west, correct? I know. That's the point. He's going to walk. It's not going to be right back down. It's going to be 2 degrees off, right? South, but he's going to go 28 over here. 20. Did I say 28? I said 28. And I told him to walk 8.1, yes? So he's going to be just 1 degree, and he's going to walk all the way down here. And then if I tell him to change direction here, what must I draw? Another one of these, and I start from scratch. All right? I do not care about this walk once I turn. This line isn't really there. Is everybody with me? Every time you turn, you have to draw a new one of these. Okay? Okay. That was really stupid to say 28. I should have said something over here. Let's pretend, rewind. I know, right? What's rewind? Skip backwards. I don't even know what you call it now. Nothing winds. What do you guys say if you're watching a YouTube video and you get past something and your buddy comes and says, oh my God, you got to see this?
Go back.
You say go back?
I'd probably say rewind it.
Because then you just tap on the phone.
All right, okay. So here I'm going to say Toby's going to walk east 41 south. Where's that going to be? East, down here. There's the 41, yes? And he's going to walk 12.2 km. Now, to do trig with this, I need some angles, don't I? This is what causes you guys the most problems. If this is 41, what's this? 49. If this is 29, what's this? 29. So what is this whole angle that he turned? 78. Everybody cool? All right. So that is angles in the real world. For the rest of this block, you are going to work on page 55. Now listen. This is the first time, yes, this is the first time you have done a textbook piece of work. Just like if you had an actual textbook, you would have the answers in the back, yes? Well, I have provided them for you. So, would I ever mark textbook work? No, because you've got the answers right there. Oh, way to go, you all got 100. Now, listen to me carefully. You're going to work on page 55 right now. Right now. It is 1:40. You are in class until 2:26. I firmly believe that these 8 questions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 questions are easily done today. I would very much like to be moving straight on tomorrow when you walk in the door. All right? Now, everything on this page is tangent. What I have just taught you over the last 2 days. Anything that isn't, for example, number 11, I did not expressly teach that to you, but when you read this, it uses words that we have used in class. Okay? Go. You may work together. You do not need to work by yourself. It is not a quiz because, of course, the answers are on it.